Okay, same as what we already learned in force. Okay, torque also have an equilibrium, but it comes with two conditions. First condition is the all external force must be equal to 0. Means that your total Fy will be equal to 0 and total Fx will be equal to 0. Okay, I will note down the example. Fy equals to 0 means that your normal force plus your weight will be equals to 0. Okay, your Fx equals to 0 means that your F applied, okay, plus your frictional force will be equal to 0. Okay, number 2, all of the external torque will be equal to 0. Means that your total torque will be equal to 0. Okay, so torque vertical equals to 0 and torque horizontal will be equal to 0. Means that for torques also, you will have your equation in which torque 1 plus torque 2 plus torque 3 will be equal to 0. Okay, so right now, we continue with example 8.8. A woman mass is 55 kg, so woman will be denoted as the smaller m, sits on the left end of a seesaw, a plank of length L equals to 4 meter. So the L will be here. Okay, pivot in the middle as in figure 8.15. So pivot is at the center of in the middle of the plank. Compute the torque on the seesaw about an axis that passes through the pivot point. Well, should a man of mass m equals to 75 kg sit if the system seesaw plus man and woman is to be balanced? So we want to make sure that the seesaw will be balanced. So when we talk about balance, means that the torque will be in equilibrium state. Okay, so right now for question number 1, we know that we want to make sure that the seesaw is balanced. Okay, so that's why the total of the torque will be equal to 0. Okay, so first, why we have 4 torque here? Okay, why we have 4 torque here? So this is the rough figure. Okay, so we have the first subject here, okay, which is the woman. We have the second subject, which is the man. We have the pivot as the third subject and third object, and we have the plank as the fourth object. Okay, so that's why we have 4 torque. Okay, first object, second object, third object, fourth object. That's why we have 4 torque. Okay, so for the first torque, which is torque of pivot, is 0. Why? Because the pivot right here, okay, didn't have any displacement. That's why it is 0. Okay, and the torque for plank also 0 because it didn't have any displacement. Sorry. Okay, and right now take a look at the man. Okay, so man, the torque for man right now, we will have mgx. Okay, why we have negative mgx? Okay, right now, okay, the weight of the man, okay, the rotation for the man, it will go downward like this. So when it is like this, it is clockwise. So as I mentioned before, clockwise will give negative torque. Okay, and for the woman here, we have positive torque because counterclockwise. Okay, this is counterclockwise. Okay, for the woman, we have positive torque because the rotation is counterclockwise. Alright, so we look at the formula torque for the man. Negative mgx. Mg is the weight, which is the force, and dx is the displacement of the man from the center of the point here. Okay, and then the torque for woman itself, mg L over 2. Why L over 2? Because the woman, okay, the displacement of the woman from the center will be denoted as the little l. So the little l is the half of the capital L. That's why L divided by 2 for the displacement here. So up to here, you can make X as the subject. Okay, and then you can substitute all the information given and calculate the X. Okay, for the question number 2, okay, you have to find the normal force. You have to find the normal force exerted by the pivot on the seesaw. So right now, you want to find the normal force here. N. So actually, when we want to find the normal force, we will use Fy. Okay, so we will use Fy. So here is your Fy. Total Fy will be equal to 0 because right now, okay, didn't have any vertical move. So you have to sum up the total Y here will be equal to 0. Okay, because you didn't have any vertical move. Okay, so you have to sum up all of your vertical motion. Okay, so right now you will have mg, which is the man, the weight of the man, the weight of the woman, and the weight for the plank, plus with the normal force of the pivot equal to 0. Okay, so you just substitute all the value of the weight and then times with the gravity, then you will get the normal force here. Okay, and for C, it asks you to repeat. Okay, repeat part A, repeat same as question A, but right now the situation is, okay, for B, the situation will be like this. This is the pivot, the seesaw here, this is the pivot. So the woman is here, okay, and the man is here. So right now, what you can see is, okay, the woman, the torque for the woman will be 0 because there will be no displacement for the woman. Okay, so that is for the question C. Okay, so we will take a look at the question C. Okay, right now, for the woman here, it will become 0. Okay, so you can recalculate dx, okay, the displacement of the man by using this equation. Okay. Okay, right now, for example, 8.9, a 50 Newton bowling ball is held in a person's hand with the forearm horizontal as in figure 8.16a. The bicep muscle is attached 0.03 meter from the joint and the ball is 0.35 meter from the joint. Find the upward force. Find the upward force exerted by the bicep on the forearm and the downward force R exerted by the humerus on the forearm acting at the joint. Neglect the weight of the forearm and slight deviation from the vertical of the bicep. Okay, so right now you will have 3 torque. Okay, where is your torque? So your first torque is at the here, at the resultant here. Okay, the weight of the if I'm not mistaken, humerus. Okay, and then number 2, the force here. Okay, the force at your bicep here, and then number 3, okay, the torque number 3 from the bowling ball itself, from the object. Okay, so first, second, third torque. Okay, everything that attached to the wall or everything that attached to the center of the axis will have the torque. Okay, so right now you have 3 torque. Okay, so for the resultant force, okay, for the owner that attached to this one, okay, didn't have any torque because the displacement here will be 0 because it is at the center of the axis. Okay, and then for the second one, for the T force, so you want to find the force here, then you just multiply with 0.03. Okay, we want to find the force at the bicep here. Okay, the displacement between the bicep and also the center of the axis right now is 0.03. Okay, so you just add on 0.03 here, minus with your bowling ball. So bowling ball, okay, will have weight which is downward, and this will be rotated in at the clockwise motion, rotated here like this. So that's why we will have negative value, which is the weight of the bowling ball times with the displacement, in which the bowling ball to the center of the axis is 0.35. Okay, so equate with 0 because it is equilibrium torque. Okay, then you can just move the 0.03, okay, to the right side, and also this one to the right side, then you will get 583 Newton. So if you want to find your R, okay, you know that the total force in vertical motion is equal to 0. So your F right now is 583. So you want to find your R, so your 583 just minus with 50 Newton, then you will get 533. This 533 Newton is for R. Okay, this is the basic force topic only. Kita nak cari R, kita dah ada force, dan kita tahu the total of all forces will be equal to 0. Okay, this is the first condition for the equilibrium torque as I mentioned in the notes given.